thank you so much for being a part of this dynamic user group. It's always a pleasure to be part of the community, which is so vibrant and really doing great stuff. Uh, so, yeah, as Vaishnavi said, I've been with Amazon for almost 2 years plus, and today I'm going to talk about one of the topics which is really close to my heart. So today, what I'm going to talk about is mastering a key operational dimension of applications, which we call it as observability, with a focus on serverless application at AWS. With microservices becoming prevalent, the granularity of each service is further reduced, right? So, which is they're operating independently and they're usually deployed in a distributed manner. This distributed nature requires a very different approach towards the overall health of the system. Getting to know whether things are fine, whether it's the performance, whether it's the availability, whether it's the overall health. It needs a very different approach because you have these small services deployed across everywhere, and you need to be in control of the bigger picture, right? It's critical to really care about the health of each component, every event that's happening inside your system, whether it's coming from the user, whether it's an event which is a change of state inside your application itself. You need to be in total control, right? It's just no more anymore about really just the high level incident management or outages, but also to have a visibility at all levels and being able to really zoom in and zoom out. So being able to really go at the highest level, have the bird's eye view, find an issue if there is any, and then be able to zoom in back to have the overall control in the system. Basically, being armed with the correct data points is hypercritical now, and it should help you carefully filter the noise and focus on the signal. So, back again, I am Kapil Gambhir, an enterprise solution architect. In this session, we will discuss AWS native solutions, providing capabilities that enable you to identify bottlenecks, issues, defects uh, proactively, right? Without you having to manually sift through so much of data which otherwise gets produced in logs, metrics, and traces that you might be having. This whole process is quite analogous to the expression finding the right needle in haystack. That's where the topic really came from, which is about the continuously generated logs and the operational data, the huge volume that's getting generated by the system today. So once again, thank you for joining the session. I believe all the slides would be available post the session, and the recording also will be available later. So let's get into it right away. So, what's on agenda today? Let's quickly cover the agenda. First, we'll define on what observability is, why it's important, and how it has evolved from the traditional monitoring. Is it really the old wine in the new bottle, or is there something, a value proposition that we see in the observability? We then go through how to actually create, view, query logs, look at the metrics, and the traces in your serverless application, and then get the whole thing together. It's very important to be able to correlate so much of data being produced and make sense of it, get some insights out of it, get insights which are actionable, right? So we'll go through that. Then we'll cover through what metrics are. We'll talk about some of the metrics which are available out of the box. We will talk about custom metrics that can be created. There is a new embedded metrics format which we rolled out, how it really enables you to do certain really nice things. We'll talk about that. And then we'll come to logging, tracing, to see a request flowing through the system. So tracing is about how do I really trace? How do I look at a request the moment it lands in my system, in my application, and traverses through different components that are there in the application before it goes back as a response, and be able to really look at behind the scenes how the system is behaving. We'll culminate the discussion uh, by bringing it all together and seeing how you can correlate all of this with a single comprehensive view. That's where the whole magic happens, right? So let's get straight into it. Okay, so this, I believe, anybody who is seen AWS serverless presentation would have seen this. But just to level set what we mean by serverless, there are these four core tenets we believe it must adhere to for truly being serverless. Firstly, reduce time spent on things that are not core to your business, right? Most of the customers that we work with, their core business is not about managing the server, not managing the infrastructure. They are in a different business altogether. So they want to focus on their products and driving their business outcomes rather than focusing on the infrastructure itself, right? So serverless enables you by not really doing the undifferentiated heavy lifting around the servers itself. Uh, then it's about the scaling, and it has auto scaling and automatic scaling to a near infinite levels, as we believe the cloud is all about. Resiliency and fault tolerance are also baked in. You don't have to really work around the resiliency and the high availability. The platform and the capability, service capability takes care of that. And then very importantly, you're paying for the business value derived. You're not paying for the servers. You're not paying for keeping the resources up and running, even if there is no request, even if there is no user, if there is no end user really consuming your application or your services, there is no infrastructure which is running, and you're, nothing that you're paying for. Only when the infrastructure, the traffic comes up, the infrastructure comes up on its own and start really responding to the request itself. So all in all, basically it leads to faster time to market and maximum agility, and that's what is really the key for serverless. Okay, so with that, with a common understanding of what serverless is all about, let's move into the core aspects of the session, right? So first, we need to recognize that there is no such thing as an application that never fails, right? As our CTO, Werner Vogels, always brings about, everything fails all the time. We have to embrace failure. These are systems at the end of the day. They will fail. There will be some component or the other that will fail sometime or the other. We must assume we will need to deal with these failures, and often exactly when you don't want them to happen, right? And this whole thing is codified in the operational excellence of our well-architected framework, focusing on running workloads effectively to deliver business value. So failure is a reality, and we have to deal with it. Deal with it in a way which is graceful enough so that your end users don't really see that or go through that experience. They have the best of the experience possible. Okay, so with that, let's look at the traditional monitoring that we are used to in the typical monolith architecture, where you have all these layers which you need to monitor. These whole layers in the stack, from the network, right from the network layer to the other abstraction layers of virtualization, operating systems, and also the business outcomes, right? So you had to kind of look through the whole stack itself, and it does get challenging. Undoubtedly, it does get. It's specifically the operation teams. They usually spend a lot of time setting up monitoring, alerting for many of these components across the layers that we can see here, right? Now, serverless kind of works differently. If you're building serverless application, platform has taken much of the burden off your shoulders, so you don't have to monitor many of the layers yourself. This becomes AWS responsibility. We look after the physical infrastructure, virtualization, operating system layers, and the platform runtime. This basically enables you to focus more on your business logic as part of your application code and data, and also have the business visibility. Very critical for you to know what the end user is really experiencing. Are business users, are the end user getting the business value? are you making the right business impact, right? So that's how the serverless kind of changes, because you can now focus on the top two layers and not really worry too much about the underlying layers. So, how has the monitoring really evolved, right? So, as applications have evolved and customer needs have expanded, right, monitoring needs to do a lot more than just watching the layers of the stacks. Customer experience has become hypercritical, very important, really. Resources, specifically in serverless, as you would know, are often short-lived. They're ephemeral in nature. Uh, as the request kind of goes back, its response back, the infrastructure might not be available anymore. At least you can't really see the infrastructure, right? So uh, there are more and more connected parts to the application. We are connecting so many things with the application. It continues to evolve and continues to talk to so many components which are globally distributed at the least. And then we are also releasing things at a very fast rate, right? The whole agility, the whole idea about iterative development, experimentation, MVPs, rolling out has a very fast release velocity. Now, to be in control of this fast moving, evolving ecosystems requires a different mindset of how to really be in total control. So what is required is being able to quickly identify the source of the problem, right? If there is any. All customers need to be able to start with infrastructure or application level views where I can really have a bird's eye view of, and that also dynamic in nature, not something which is static, right? Something which is a reflection of what's really happening inside the system. Real reflection of the traffic, real reflection of the problems if there are any, real reflection of the connectedness between these systems altogether, right? And if there is a source of problem, the customer should be able to identify and quickly drill in, right? Just zoom in into the resource where the problem is emanating from, look at the logs, look at the matrix, be able to correlate them, and understand the problem with the whole context being available to you. So if you're looking at the logs in isolation, you might not really realize, you might look at an error, but you might not really fully be able to understand where this started from, who is the caller of this call, where was it going, what was it trying to do. So getting the whole context when you're doing troubleshooting is really critical. The other critical need is the end user experience of the application, right? So this is core to the business outcome of how application is being used and how traffic is flowing within the application and facing any potential bottleneck or issue. It directly knows, helps in knowing the business impact. Very critical, really. So with serverless, you have access to more granular information. Now your components are executing as functions. So you have very granular information about where the function, which all functions are doing well, which are not doing well, where is the potential for improvement, where is the challenge, where there is probably an issue, and you can convert that or look at them from a pure business metric perspective. Whether my customers are able to do the payment in a fast way, whether they are able to book whatever merchandise you have to offer, is there any issue all around that? So you look at it from a very business oriented mindset, which is really very different from the way we were doing the monitoring part earlier, which was largely technical. So I mean, with all that said, we now come to the concept of observability, right? Which is the core idea of this session. So this word is derived from control theory. While monitoring can be seen as probing, querying, and reporting on different aspects of your application, observability is a measure of how well internal states of a system can be inferred from knowledge of its external outputs. I'll repeat that. Observability is a measure of how well internal states of a system, which is how what's going on in the system, can be inferred from knowledge of its external output. So how well have I really put the probes in my systems? What are the telemetry that I am receiving? What information am I getting out of it? And is that something which is good enough for me to really know what's happening inside the system and be able to kind of one, be aware of it, and then if required, act on it and really make sure things are working fine. Observability is having more visibility into the system as a whole, not just knowing you have a problem, but understanding why is it happening and hopefully also creating a path of resolution. I like to think of it as being able to see the big picture from outside, looking in, and then to be able to work out everything that's going on in an application and be able to zoom in and zoom out depending on the requirement. And very critical again, without losing the context. So if I'm zooming in, if I'm going to the logs, I should be able to look at the traces around the log, should be able to see what were the various communication where the request was flowing while these logs were generated, and the context really plays a key. So observability is really critical. So we focus on observability in this session. There are three key pillars of observability, right? So matrix, log, tracing, something we've already mentioned, and importantly, kind of correlating all of these together and providing a contextual link between them. So matrix, as we primarily understand, gathers numerical data about things you want to track for your application. Think of them as request rate, error rates, and probably some business metrics such as number of orders placed, payments received, and all that, right? So the numeric, a time series data which kind of gives you an idea of how things are performing over time. Logs are timestamp record of events, something happening at a point in time, a failure, an error, something informational, such as state change. Log may have certain metrics included in them, and we'll talk about it more in some time. And then finally, the traces. Traces are a single user request or a journey through a number of separate components of our application, the services which are kind of bringing the whole of this together, and kind of giving you a very visual way of looking at how different requests have traversed your application. To exemplify, if I'm alerted on a metric, I should be able to see the associated logs and traces with a few clicks and easily navigate between them and try to understand the various components involved. If I can do that, if I can spend less time working out what's currently wrong and have more time fixing the problem, uh, I think the overall business objective is served, right? So that's what we will talk about. So for observability, these three pillars need to contextually correlate to bring better visibility into the system. You need to make sure you're collecting enough data to actually understand the system. Debugging is super important for observability. Using the data you collect to help with quick troubleshooting. Realistic testing honestly also happens in production, right? So not just in an isolated test environment. As often smaller components are released, more often testing these smaller changes in production becomes important. It's critical to really be aware of as and when I'm rolling out the changes, whether they are working fine. I should have a clear view of the matrix, the clear view of the traces, the information that's being generated. And at any point, if I see that they're not really matching the pattern that I expect, it should be easy for me to roll back the incremental change and bring it back to the stable version that it was earlier. So from AWS perspective, we have two main services to help with the overall goal of observability. That's it. That's AWS Amazon CloudWatch and AWS X-Ray. Now, CloudWatch is a service that collects monitoring and operational data in forms of logs, metrics, and events. It also gives a very nice unified view across your AWS resources, application, and services. You can set up alarms if something is important. You can visualize your logs and metrics pretty easily, and you can take automated actions, very importantly, based on what is happening in your logs, traces, or the metrics itself. X-ray, on the other hand, is the tracing service. It helps anybody who wants to look at the data, analyze it, debug the environment, and it's particularly helpful for those built with multiple distributed components which are working together in tandem, so that you can see the requests, see the journey really moving across, and be able to understand where are the hotspots and where things are working fine. So CloudWatch and X-Ray have a number of services, and They probably are big enough to really be talking about them in a separate session itself. But primarily, these are the four capabilities, the four breadth areas that we talk about. So first, they allow you to collect the logs and metrics, right? The information needs to be collected. Then you monitor the collected data using dashboards, alarms, so that you can see what's going on, view history, and spot trends, right? Then you can act on the data you've collected, you're monitoring, you would want to act on it, right? With alarms, if an alarm is fired, either based on the threshold values that were defined or anomaly detection that could be used, you can then send an alarm or run tasks automatically to do some rectification, and you can also do canary testing, right? In the end, it really helps you also analyze the whole thing, whether it's a log by running queries or visualization or analytics using higher level services like service lens, something which we'll see to analyze your application across the whole thing. But CloudWatch and X-Ray are not the only options. Pretty much like everything else on AWS, we have a broad partner ecosystem with some amazing monitoring and observability products and features. In the interest of time, we would not be able to cover those today, but some of the partner integration offer a lot more than just monitoring or observability. I would strongly encourage you to look at these options also. Developing serverless application doesn't have to mean you can't use your existing tools if you're already relying on those partners. So the idea is to make life easy, things that you're comfortable with, you should be able to carry forward in a serverless application. Okay, so let's delve into the metrics pillar. First, let's talk about the metrics that are available to you without you doing anything at all, right? So once you have the application deployed, CloudWatch comes with a number of standard built-in metrics. It gives you the telemetry right away without you really putting in any probe. And these are important, more important in the serverless environment because you can't really log into a server there and kind of look at this data. We have to provide you all this data baked out of the box itself. These are automatically generated when you're using Lambda, API Gateway, and many other serverless applications or services that we have to offer. Lambda, as you can see here, offers 13 built-in metrics covering various invocation, performance, concurrency metrics, so that you can easily see how many functions that you have deployed, they're executing, how long they are taking, what invocations are you getting. There are also many concurrency metrics for seeing how many functions are running at the same time. Very important for a serverless function perspective. From an API gateway perspective, we give you 7 metrics out of the box, which show you how many API calls you're receiving, along with any error counts and the cache details if you're using caching in the API gateway. HTTP and WebSocket API also gives you similar metrics. Remember, these are automatically generated, so you don't have to do anything for really looking at this matrix. But as helpful as they are, the built-in matrix are not enough. That's the lowest common denominator, but typically we have seen you would need more visibility into your application, and not just at the infrastructure application level that you're looking for. You may need to track your business and customer metrics. How is your application performing against your business goals? Are you generating the revenue you need? Are you getting enough people signing up for the awesome service that you've created? Are customer uploading the number of tracks you expect? So a very different perspective of looking at it from outside in, from the business outcome perspective. Similarly, operational metrics are also important for observability. How often are you safely deploying? How long how long does it take for you to recover from failure? Right? These are important operational metrics. What if you want to create metrics for a particular category or environment? Another dimension altogether, right? This is why you need custom metrics. These are the metrics that are specific and custom, important for you, your application per se. And you can generate custom metrics by instrumenting that in your code. I have a sample on the right hand side of the screen. As you can see, this is a Lambda function. You can observe that it's spitting out a specific data point capturing data has a dimension called write. And let me see if I can uh, show you this. So this is where the write is being captured, right? So and then it goes out and sends that data to the CloudWatch matrix. This basically illustrates that you can publish fine-grained data matrix based on the function capability. If there is something custom that you need, it's pretty much feasible using the custom matrix that as a sample that I'm showing here. This is improved by something we call the embedded metrics format, and that's something which I'll cover shortly. Okay, switching to logs now. CloudWatch logs generates operational data for a number of AWS services. For API gateway, REST APIs, you can have execution logs and accessing logs with two levels, error and info. You can also choose to log the method request body, the response body content for a deeper troubleshooting analysis itself. Now, the API gateway REST API logging is either set globally in the stage of an API, or you can override the global setting at individual methods if required. There is also CloudWatch logging available with the new HTTP APIs and WebSocket APIs. For Lambda, there are some log lines that we capture automatically for every single request. Things like the duration of time. We also capture if there is some error. But if you additionally want additional data to be there in the logs, you can directly do that from the application code using the standard debugging like console log statements or whatever is the equivalent of your function language of your choice. This is useful for logging basic request information. Pretty helpful when the code is deployed and you're totally dependent on this information to tell you what is going inside the system. You can also create JSON structured logging. We'll touch on that, and also use our new embedded metric format. Once you have your logs created, you can do a number of things with that, right? That's the base data for you. You can filter them, you can create metrics for them, or even ship them off to somewhere where you can do the analysis, with popular options being Elasticsearch or using S3 with Athena being as the interactive query service too. So looking a little more at the structured logging, here's a structured logging message format, which may be part of your event. Your Lambda function is working on your application. This has number of fields. You can do a language equivalent of the language you're using in your function. In JavaScript, you can use the console.log. In the Python, you might have a print statement and so on and so forth to send these CloudWatch logs messages. This gives you some basic logging information and appears as text line in the logs, but it's difficult to correlate and often have the whole complicated system give you a value of just by the just the text message, and not really any having metrics provided from that. That's where the embedded metrics format steps in. So to help you with this, AWS released AMF to publish logs using a specific format. This allows you to embed custom metrics which may be part of the event payload alongside more detailed log event data which could include invocation information. These then get automatically exported as matrix, right? So while you are generating the log, the structure of the log is such that it will automatically generate the matrix without the need of any additional processing on your part. And that can be consumed directly in the dashboards, even in the alarms also. There are open source client libraries available for Node and Python. And I have a snapshot here which kind of shows you how this can be done. You can see the structure of a JSON embedded metric format log here. You can see this function includes the Lambda function invocation information along with the metric in this case, time in a specified unit, milliseconds. This log with the included metric will then automatically be exported to CloudWatch Matrix so that you don't have to ship your console.log somewhere else to then have a whole process of extracting the matrix or kind of analyzing the data that you're looking for. Now, one thing to mention here is that embedded metric format is more verbose. as there is more information here than the typical console.log messages. It's certainly more useful information, but it will impact your CloudWatch logging billing. So make sure you're managing your log size and using appropriate retention policy, which is anyway a recommended practice. So we can go a step further with this. One of the great things about the embedded metric format is that it allows you to use CloudWatch insights also, which are primarily helpful to drive actionable insight from the log. This allows you to do more complex queries. Say you're looking at the top 100 longest Lambda execution, right? This query creates a report, the sample that you're seeing here, which gets a request ID and then also retrieves and sort by the build duration, right? Something which is important from the overall cost perspective. And then it displays the top 100 in the results. You could use this to filter out any Lambda function across one or more log groups that are taking longer than expected, and maybe investigate them further for any potential performance issue that might be there. Or you could just be improving on what the current state is. You could also use this to know where you can look first to save the cost by finding the most expensive Lambda execution. Similarly, another example, here we're talking about finding the most recent 100 errors. This could help troubleshoot and pinpoint function errors without having to navigate each function across the logs group manually, right? So CloudWatch Logs has also added recently the saved queries for insights. This allows you to save and organize queries in folders and then easily run them again, even for a different purpose by another team or another application. And for all you may know, you might want to include them in the run books so that it becomes easier for your operational team. CloudWatch Insights gives you some powerful querying and analytics capability to get insights into your logs. Okay, now moving on to the last pillar, which is tracing. Tracing, as we discussed, is about understanding the path of different events as it propagates through the components of your application. X-Ray is our service for tracing. It basically provides a distributed tracing solution from AWS, which provides an end-to-end view of requests as they travel through your application and shows a service map your application of the underlying components. Again, purely dynamic based on what's happening under the hood at this point of time. X-Ray collects data about the requests that your application serves, which helps you understand how upstream and downstream services may be affecting the workload that's currently deployed. You enable X-Ray for various AWS services, including the serverless ones like API Gateway, Lambda, SNS, SQS, and AppSync included. For Lambda, you enable X-Ray and then optionally instrument your application code to add tracing data if you need more fine-grained tracing for different things that you're doing inside. For API Gateway, just by enabling the active tracing, it reports data to X-Ray as well as inserts tracing headers into the HTTP calls, which can then flow into your Lambda function. So you can know which API Gateway call is associated with which Lambda function. That's the correlation under the hood phenomena, that the mechanism that the platform is using. X-Ray receives data from services as segments, which we'll see shortly. Segments for a common request are then grouped into traces. Segments then can be further broken down into more granular subsegments. You can then add custom data key value pairs with annotations and metadata, very powerful concepts, which are custom description of how you can add information to your instrumentation that you're producing. So you could, for example, capture the payment ID generated by a third-party service and see how that flow is going across different functions. This is a quick example of Node.js. So you can see on the top where we're including the AWS SDK and the X-Ray kind of covering that to kind of ensure that the X-Ray instrumentation is produced. And then in this case, we are instrumenting the S3 bucket activities. So all the S3 bucket activities related would kind of come into tracing. There is an option to individually select the service if you don't want to do a blanket coverage like we have done here, where you would want to cover specific services only. That capability also exists. Now, AWS X-Ray also creates a very nice visual map of services used by your application with trace data so that you can use to drill into specific services. As you can see here, you can see the connection between different services, and you can create dependency trees and be able to kind of see if there are certain issues by the different visual colors that we give. Looking at the individual traces, you can see the specific errors. In this case, there is something related to the S3 access, right? So this kind of makes it easy for you to makes it visual, intuitive, and easy for you to really look at the errors. Now let's focus on bringing the whole thing together. Let's change gears and kind of talk about the magics as to how this whole thing comes together to give you a much higher aggregated value. So last year at reInvent 2019, we announced Service Lens, which really ties together CloudWatch metrics, logs, and traces more closely to give you a complete view of your application and their dependencies. Think of this as a single pane of glass, which enables you to more quickly pinpoint performance bottlenecks, where the issue is, have a better idea of how users may be impacted. Log and metrics are automatically captured to the base level, but it requires to enable X-ray for this to come up. In addition, another part about the end user experience simulation is facilitated by CloudWatch Synthetics, which allows you to monitor web application using modular lightweight canary tests. This is done by creating a canary using existing blueprint or a script that you might have created. Then you set up thresholds where you want to be alerted. Finally, you can troubleshoot failure using features like getting the snapshots of the screen that your customers might be seeing once you run those canary tests, and also have the HAR file, which is the HTTP archive file, which is the standard format to help in understanding the browser interaction with the site. So you have the whole thing to analyze in a much easy fashion. Really helpful to really look at the whole application from a customer perspective. We'll just look at certain views just to get a better sense of it. So this is a typical application where you have multiple nodes kind of talking to each other. This kind of helps you quickly visualize the whole application at a single shot. This is a typical application in production, right? So where your multiple components are collaborating together for a much bigger purpose. This is all dynamically generated based on the requests that are flowing in through the system right now, right? The thicker lines are interactions which are happening more often. The thin lines are where there is less interaction. So it gives you a sense of where the traffic is maximum flowing, right? And then similar is the case with the node size. It has modes, or two modes for now, right? So there is a request mode on the top right hand side, as you can see, which kind of shows the whole information, the visual basis, the request data. And then you can switch it to a latency mode so that the size of the nodes and the edges are kind of reflecting the latency in the application itself, right? So you can focus on, for example, the areas where the latency is higher and kind of drill through that. So this is another application where I'm just showing a view where I've clicked on a particular Lambda function in the service map, which is part of the service lens. And then I could see here the matrix correlated to it. So as you can see here, alert is being triggered. So bottom right, you can see the alert is being triggered with 3 metrics being available about latency, request, and faults over the selected time period. With the requests specifically broken down at P50 and P90 to understand the change on those specific percentiles over time, as you can see in the graph, that orange and the blue line down below. Going to the second pillar of traces, to understand the request flow and visualize application performance, it shows where your P50 of your application stands versus P90 and P99. To get a good understanding of the variation and how many requests are falling into which zone. For those traces that we saw, one can get into the details and look at further segmentation of those requests. So the thing that I was initially discussing about how the request is flowing, you can look at the finer segmentation and look at the components that the request has traversed through and understand how much time was spent in each component and what requests, what response code was observed, right? The green is good, the red is obviously a concern that you want to take care of. Coming to the third pillar of the logs, in the same context, while you're looking at the traces, if you kind of scroll down, you would see that where you were looking at the tracing details, you would go down, you will look at the correlated logs for those traces. So it's all happening in context of a bigger view that you were looking at. It helps you troubleshoot in cases where there are any issues. So this is the overall summary of how it comes together to give you a consolidated view, something where 1 plus 1 becomes 11 and helps you traverse different levels of your applications, kind of zooming in and zooming out. So in a nutshell, a typical troubleshooting workflow, the way I look at it, would start with a notification based on anomaly detection or an alert which would trigger an alarm. The moment you get that, you would open up the service lens, take a look at the service map to visually identify if anything stands out, like anything is red or there are bigger circles. Then you would dive into the traces to understand where the call failed, which call failed, why it failed. Uh, and then you could look at the X-ray analytics, something which was rolled out recently again, to understand how its performance has changed over time and got to where it is right now. Is there any correlation with the other errors that you're seeing? And in the end, you could use log insights to search for similar situation with the log information to look at the specific issue. This is where the log data kind of helps you trace back to the X-ray data which was available. So in summary, we've gone through many concepts today about observability, and hopefully we now appreciate how it's more than just monitoring the traditional monitoring which we used to do with microservices, distributed architecture in place, how correlating different data points presented in three pillars of logs, metrics, and traces helps in being able to achieve better operational effectiveness, how tools like CloudWatch and X-Ray helps you, the embedded metric format, which gives you a dual power of logs with automated generated matrix, and finally with Serverless Lens, how all of this comes together and gives you a single portal for desired visibility and troubleshooting. Thank you so much.